So this is Monday, January 9th at 2 o'clock. It's science time. And this science lesson is on the science of sound. It's lesson 5.03 on sound energy. And I have got actually 3 different sound things to teach us more about sound that we can do today. But in the meantime, if you need to work on that science experiment, you may go into a breakout room and work on it. I had given names to the breakout rooms because I thought there might be a lot of kids and we could split up. But with so few kids, we'll probably just watch something together in here. So if you need to go work on your science experiment, you can do that. In the meantime, I'm going to leave room 1 free so that the book club can go in there in a little bit. And I'm going to leave room 2, 3, and 4 for kids to work on science experiments.
So are we still gonna be doing the science today? Or not?
So I'm not going to go through the science with you.
Okay, so
If you need help with it, let me know. But in the meantime, if you're not coming in person and you want to work on your science, then you can go to a breakout room and work on it and come back if you have a question. We're going to watch a video in this main room about the science of sound. So stay with me if you want to watch that, if you're planning to come in person. But if you're not planning to come in person, let me see here. Did I make it so that you guys can get to the rooms?
Miss Les, my auntie asked my dad if we were gonna come, and my dad didn't answer. So she last time we had an in-person thing and I didn't come, he said, "Why didn't you tell me I could arrange something for work?"
Well, why don't you tell him?
Well, I forgot the last time, but I think he's probably gonna say yes.
Okay. So again, if you want to come in on Thursday, we're going to do this experiment 503 in person on Thursday. If you're not coming in on Thursday, go to a breakout room and work on it now. In the meantime, I'm going to share my screen and show you a cool video about the science of sound. So here we go. Share and go to YouTube. Why does it say that? Oh, there we go. And type in Kathleen Bell. Let's see if it pops up. Sound energy. There she is. All right, let's try it.
Hey everyone, it's Ms. Bell here again from the Science Lab, and today we're going to be talking about not only 1, but 2 types of energy. Can you guess what they are? Let me give you a hint. And whoa, oh, oh, whoa, oh, 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 oh. Ha. Ha. Yes, it is sound and light energy.
So when we talk about sound energy, basically that's just a type of energy that we can hear with our ears. And when an object vibrates, maybe it hits something or something comes in contact with it, it causes movement in the air around that object. And that creates sound waves. And those sound waves travel through the air to our ears, and that's how we can hear sound. Now, when you talk about volume, that's either how soft or how loud a sound is. And with pitch, that either means how low or a sound sounds. And when sound energy happens, all those vibrations moving through the air, they can either go really slow, and that'll be a low pitch, or they can go really fast, really fast, really fast, and it'll be a high sounding pitch.
Here I have all sorts of different bottles, some made out of glass, some made out of plastic, some empty, some filled with water, and I want to play around with the sounds and the pitches and the volumes that I can make from these musical instruments. Let's see. And you can even make a musical instrument like a trombone if you get a bottle and fill it with water and place a straw in, and you can move the straw up and down in the water and hear the different sounds. As my straw moves further down into the water, that pitch is really, really high and squeaky. And as I move it up and blow into the straw, it gets lower and lower in pitch. Okay, right here I have a musical instrument that I tried to make here in the science lab. And all you really need is some sort of sturdy box, a really big, stretchy, but strong rubber band, and then something like test tubes or maybe thick markers to use. So with this, we are going to keep this one on the right still, and this one on the left sliding away from the other tube and close to the other tube. And what we're going to pay attention to is how close the two tubes are or how far away the tubes are. And we're going to look at the length of the rubber band right here between the tubes. So here is a long length, here is a kind of medium length, and here is a short length. And with the length, that is going to help us hear and determine what kind of pitch it's going to have. So if it's really far and the length is long, it's going to have a low pitch. Can you say that? Low pitch. And then if they get closer, it's going to have a high pitch. Can you say that? And you can adjust the distance from each other. So long, medium, close together. And you can play around with the different pitches and the different sounds that you hear. And here I have two little containers with cut up balloons stretched over the top and secured with the rubber band, almost to where they replicate drums in a sense. And on top of the drums, I placed some items that are considered to be kind of lightweight, like little straw pieces, little grains of rice, some sand, and even some pom-poms. And we're going to take a metal can and a metal spoon, and we're going to tap, 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 tap on the can with the metal spoon all around our little drums. And we're going to see what happens, if anything. What do you think? If I bang on my can close to my drums with all these lightweight objects, are we going to see something happen in front of our eyes? Or will it depend on how close I am to the object versus how far away? What about the position of my can? Does that make a difference? Does it need to be with the holes, I don't know, facing my drum? Could it be facing away from my drum or facing this way? What about on top versus to the side, the front or the back at an angle? Doesn't matter. That's what's so fun about science. You get to have fun and explore. But I'm going to bang away and we're going to see if anything happens to our drums. And if it does, then why? Why does that happen? Let's find out. And here I have another setup of bottles filled with different colored liquids. And each bottle has a different amount of liquid inside. So this bottle has more of a liquid volume inside versus this bottle. And this bottle has more liquid inside than this bottle. And with the amount of water in each bottle, it's going to affect how that bottle will sound as far as pitch goes. Will the sound be high and squeaky, or will it be low type of sound? And the more water that is in the bottle, that's going to be a high pitch, so squeaky, high, high, high. And if there's little water or even no water, so the less amount of water is going to be a low sound pitch. So here's our low pitch sounds. And then as I go this way, it gets higher pitch. Here we go. High, low. Let me try blowing in them, see if that makes a difference in sound. You can even play this type of musical instrument and make up songs. Can you name this tune? Here we go.
Guys know that one?
Hey.
Mary had a little.
Okay, so for this little demonstration, I'm going to use a tuning fork and a metal spoon. And then back here, I have a stand that has a little styrofoam sphere taped to a string that is attached to the very top. And that will allow my little ball to swing freely. But I'm not going to touch the ball myself. Instead, I'm going to let science be the one to move the ball. So what I'm going to do is just tap my tuning fork with my metal spoon, and I'm just going to barely touch the tuning fork to the ball, and we're going to see what happens. So basically, after I hit the tuning fork, there's going to be vibrations, sound vibrations, moving through the air. And as they move through the air and my tuning fork comes into contact with the ball, those vibrations with that slight touching, it's going to move the ball. And we're going to be able to see how those vibrations can be visible at times. Because if I just do this, we can't see anything. Of course, we can hear something and it sounds lovely, but we can't see those vibrations. But you can definitely see it with this demonstration, because I'm not over here banging on the ball. I'm just barely putting my tuning fork up against the sphere. Okay, so I have my tuning forks right here. I have one in my hands, and I'm going to just hit the tuning fork so we can hear what it sounds like before I ever put it in the water. And now I'm going to hit it and then quickly put it into the water, and we should be able to see those vibrations moving the water and making ripples. Here we go. One last experiment I want to talk about with sound energy is these cups right here. You might just think, Ms. Bell, what are we looking at? Cups with some string and these purple things floating underneath them? Well, they have a purpose. And with this little experiment, I'm gonna take just regular string and a sponge, and I'm gonna pull or drag my sponge across my string, and I want you to see or hear if there's a sound. Let me do it again. I mean, we can hear the scratchy sponge kind of pulling against the yarn or string, and yeah, it's like a slight sound. Let's take that one step further. Do you think or predict that anything would happen if we add a liquid to our sponge? I have some water. I'm gonna get my sponge wet, and I'm going to squeeze up all of that extra water, and we're gonna do the same thing. And I want you to see if, I don't know, there's a difference in sound. Okay, I got my string, I got my wet sponge. You can already see how the sponge looks different after we got it wet. Let's see if it sounds different. Oh, it has like a, hear it again. Oh, what? It sounds squeaky. So by just simply adding water to our sponge, we were able to see, or hear, I should say, that sound difference. Now, what if we do the same thing, like what I have over here, with a cup instead? All of my sponges are wet. Let's see if there's a sound difference. Come on. Did you hear that? Let's try to, oh, hold on. That's so cool.
Okay, that just
It
sounds,
sounds like a really old door at a haunted house. Let's try a different one. Let's try this small one.
This is due today, right?
it just sounds a little rude, doesn't it?
Almost
Yeah.
looks like a chicken.
Weird
Let me try
chicken.
this red Solo cup.
I'm just wondering, is the sound energy seem due today?
Sorry, I can't hear you. What's that?
Is the sound energy working?
Wait, I gotta stop it. What's that? Ask again?
Is the science due today?
If you're not coming to in person, then yes. So you need to work on that. And there are some breakout rooms open if you want to go work on it.
Okay.
All right. And then we have book club in a little bit for the Untitles.
Almost sounds like a frog. Ribbit, 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 or a toad. Croak, croak. Last one. Let's see what this one brings.
Okay.
Sounds like a rocking chair. Or just all these croaky, amplified sounds. And that's because the wet sponge rubbing against the string like this, it causes what we call friction. And that friction moves the air all around it, giving those vibrations throughout the air, and it travels up the string and in the cup. And then this almost acts like a speaker. It amplifies that sound. It makes it so much louder than when I just had my regular string and I was pulling my wet sponge across it. We could hear it barely here, but we could hear it so much louder over here. Isn't science so fun?
All right. That's the science of sound, folks. if you are coming to in person, we'll be doing that worksheet together. If not, go ahead and get that experiment set up. Christian, you have a question?
Yes, I'm trying to do it, but it says it's blocked.
It says what?
It's blocked. I can't work on that sheet.
The lesson?
No, the sheet, the worksheet.
So you can open the lesson.
Yes. I can
Yes. Let me see. Let me go to it and see what's going on. I forgot to escape that. Okay. So let's go back to not that. There we go. Let's go to science. Let's go to the worksheet. And you also have it in your printouts, buddy, which I think it's a lot easier to work on the printout. So if you go to the lesson and then you just go to the one just before. And let's see why it's not opening. Sound energy right here. This is the one you're saying is not opening for you?
No, it was opening, but there's something that I always click to write on it, and it says that it's blocked.
Did you load Cami the other day? This purple thing right here that I have that says open with Cami?
No, I couldn't figure out how.
Do you want some help doing that right now? Yes, no, maybe so. Because I can't solve like individual problems of why it's not loading for you. You have to solve that, so I can help you work on it if you want, Christian, but you'll have to share your screen with me. Everybody else, if you are in the book club, please head to room 1, where it says book club at 2:30. And Maestra Jenny will be in there in about 5 minutes to join you. Make sure you have your reading done. Christian, share your screen with me. Let's see if we can solve it. Kainoa. Oh, that's not Kainoa. Okay, so click on the sound energy thing. Oh yeah, so you use that little S thing. Well, I don't think that S thing works very well, to tell you the truth. Give it a try right now. Click it right now and see what happens. Or
Actually, it works always for me. I always use it.
well, your last one looked good. It says pop-up blocked, but that's different.
Yeah, that's what it's telling me. That's blocked. I don't know.
Well, you have to unblock your pop-up. So click on that little red thing up above. Yeah, click on that. Click on that. And then click always allow pop-ups. And now go done. And now go back and open it again. So go to the back button and go, oh, there, try it again. And try it again. Yep.
When is in person again?
It's Thursday. Approval required.
Like this week?
Yeah. Like in 3 days. Okay. Approval required. The app requires your administrator's approval. Well, I don't even think I can do that. Let's load Cami. So I want you to go to the top and open a new tab. Go to the very top, click plus. Now type in Chrome extension, CH R O. And there, it's about the 4th one down. Do you see where it says Chrome extensions? Yep, click that. Up, there, click that. Now click Chrome Web Store, right where it's that, yep, right there. And now type at the top, K-A-M-I, Cami, K-A-M-I. Just push enter. Don't click anything. Just push enter or return. There it is. Now click Cami for Google Chrome. Now click add to Chrome up at the top there. Yep. Click add extension. Okay. Now go back to the lesson, Sound Energy 503. Now click it. And now click the K up on the top right, the purple K. No, 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 not that. Yeah. Try that one. Log in with Google. I think you really only have to do that once. Choose yourself. You have to click on yourself. Great. And go down to allow. So scroll down and say allow. It'll only ask you this once. Keep going, down, 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 allow. Yep. And boom. So now go over to the left and click on the little square with the pen, other side, down to the first black thing. There, click on that, nope, at the top, up, one more, there, click that. And then it'll open up the other side. Now click the middle one of those 3 pencils at the top, the middle one. Nope. One down there, freehand highlighter. Nope, the middle one, honey. One up there, right there. Click that. All right. Oh, actually, that's for highlighting. You don't want to highlight, so click the top one. Sorry. No, click the bottom one. Try the bottom one. Now up, 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 up. Where's the pen? Try the text, the T, the big T. Hi, Meister Janny. I think I've got kids for you in room 1, or they're supposed to be.
Okay, thanks. I should have just gone and looked.
And Jax was here, but he took off. And
Okay.
I think Amadi was going to miss today. Liam's here, but I don't know if Kainoa is. You'll have to check and maybe send.
Yeah, it's only
boys.
Liam right now.
Yeah,
I'll
so
just check
maybe
in with him.
Have Liam write to those boys, and I'll check. I'll go on Lightspeed
Okay.
and prompt them in.
Okay.
Okay, good. Christian, is that working for you?
Yeah,
Okay, go for it.
right here.
Yeah, you can type. You have to do the experiment. Did you do the experiment?
No.
Well, you got to do the experiment according to the book. Okay, so you got to get some glasses that are the same and fill them with water.
Glass? I don't have any glasses.
You don't have any cups to drink out of?
I have cups, but no glasses.
Are the cups made of glass?
No.
Okay, do you have anything made out of glass? How about you come to in person? Not gonna happen?
Nope. I can't.
All right. Well, do your best to read through the experiment and they'll talk about it online, okay?